Okay, let's give you guys some more practice. So find the limit of this sequence as n tends to infinity. So by right, I should have brackets around here, but let me just keep the screen clean. So anyway, have a go. Find the limit of this sequence as n tends to infinity. So press pause and have a go. Okay, so to do this, if you look at this bit here, so you've got when you have a square root of something, the square root graph looks like this. So the square root graph, the square root of x will just keep on growing and growing. So here you've got a square root of this thing here. Well, this thing here, 3 to the power of n, as n increases, this thing is just going to keep on growing and growing and growing. So when you square root it, then this whole thing here is just going to keep on growing and growing and growing. It will eventually get to, well, it's heading towards infinity. So the point is that this thing here is just going to keep on growing and growing and growing. So you've got 1 divided by something that will eventually get very, very large. So that will mean the whole thing here will head towards 0. And then remember this thing here, if this here is less than 1, well, you've got something times by itself n times by itself. You can see that the denominator will eventually get very, very, very large, and the numerator will still be the same. So this is going to head towards 0 as well. So you've got something that's heading towards 0 plus something that's heading towards 0. So the limit as n tends to infinity will be 0. Okay, so next one. So find the limit of this sequence as n tends to infinity. So press pause and have a go. Okay, so to do this, we are going to make use of this. We've seen this whole thing before. So, but to solve this, we are going to make use of this. Remember, nth root of n as n tends to infinity tends to 1. So this thing here is the same as this, n to the power of 1 over n. So remember the limit of this tends to 1. Just remember that. So to do this, have a look at this. Have a look at this bubble here. As n tends to infinity, you've got something to the power of 5 plus something squared. You see, this squared here is going to be insignificant as n tends to infinity. If you're looking at, let's say, 1000 to the power of 1000, a very large number, and then when you square it, this is going to be much more significant than this n squared. This n squared is going to be next to nothing in comparison to n to the power of 5. So as n tends to infinity, you can imagine this bubble here as being, well, forget about this. This is not going to be, it's not going to be significant. So it really boils down to this thing here. So it really boils down to n to the power of 5, and then take the nth root. So rewrite this as this to the power of 1 over n. So rewrite this as 1 over n. So now this is n times n times n times n times n. So now we imagine this to be a 1. So using the laws of indices, you can multiply this with this, multiply this with this 1, multiply this with this 1. That will then give you this whole thing here. Remember the limit of this as n tends to infinity. It is actually it's heading towards 1 because of this. So it's really heading towards 1. So this is going to be 1 times 1 times 1 times 1 times 1. The limit will be 1. So if you get a graph plotter, plot this. You can see that it is heading towards 1. So really, you can change this to a 3, to a 4, and it will still head towards 1. Okay.